Hi, this is your help video for 2.4, Graphing from a Story. Let's jump in. There are 12 Sour Patch Kids in a bag. Well, let's just stop there for a minute. That means you're starting with 12. And at noon, you begin eating them at a rate of 3 candies per minute. Cool. Well, and they even were so kind as to give us the equation right here, already written out. That was pretty nice. So let's go ahead and graph this. This says we're starting with 12. So I'm going to click at 12. And then I'm going down 3 every minute. So I'm going to go down 3. 1, 2, 3. That's 3 every minute. Okay? Now, what I'm noticing some students do is they go down 3, but they don't go over. Let's think about what it would mean if you did this. If you did this, this would mean that it goes down instantly. That you ate that you had an infinite number of candies, and you ate an infinite number of candies all at the same moment. Well, that's ridiculous. That's impossible. You can't have an infinite number. It's like, how many candies do you have? The line just goes up forever. How many candies do you have? It goes down forever. That's impossible. So let's not do that. Let's do this. This says you had 12, then you have 9, then you have 6, then you have 3, then you have 0. So after 4 minutes, you've eaten all the candies. Let's go on to the next question. A phone company charges for services according to this formula. Now, this is a little bit of an old-fashioned question because your phone plan probably is different than this. But it used to be that phone companies would charge you a monthly fee, and then they would charge you an amount per minute that you talked, or per text, or whatever. And I understand that most people have unlimited text and unlimited minutes. Not everybody does, but a lot of people do. And so maybe you're not used to thinking this way about a bill, but let's just take it this way. Now, electricity bills and gas bills and water bills work this way, where you have a monthly fee, and then you pay a certain amount for how much you use. So you can think of it as not phone company, but something else. Here, the rate of change, let's think about what the question is. The rate of change, which one of these is the rate of change? Well, it's the one next to the letter, because that's the 0.04 per minute. So here we're going to put 0.04. So the rate of change, or the slope, is always the one that's next to the letter. And that is going to be dollars per minute. So in this case, $0.04, that's 4 cents. Another way to say that is 4 cents a minute. Now the initial value is 11 because that's your $11 fee that you have to pay per month, whether you talk on the phone or not. All right, let's jump on to the next one. The number of shoes made at the Sprints factory. So here we have the number of shoes can be represented by the equation S equals 89H. In other words, the shoes are equal to 89 for each hour. That's how I would read that. 89 shoes for each hour. So let's look at the graph. Where would you start? Well, I think an easy place to start is how many shoes would you have made in the factory right when you open the doors of the factory. First thing in the morning, you unlock the doors, people walk in, start punching in the time clock. How many shoes have you made? Well, 0. I think we all understand that. You haven't made any shoes yet. You just opened the factory. Then after 1 hour, you've made 89 shoes. Well, where would 89 be? Well, this is 200, so it'd be a little less than halfway to 200. And you could think about where else to put these dots, but I think that that's the easiest way to do it, is just try to think about, I put that's at 2 hours. I better put it like, maybe like that. So maybe at 2 hours, it would be twice of 89. Twice of 89 would be 178. So at 2 hours, it would be 178. Yeah, maybe. Let's see. You're just going to have to get it close. Oh, I can't. There it is. Now I can hit submit. Oh, it was close enough. Cool. So just try to get it close. But the key on this one is to make sure that one of your dots is at 0. That's really the most important thing. All right. Suppose you're in a submarine 40 feet below the surface of the water. You are ascending. That's going up. You're ascending at a rate of 5 feet per minute. And here we, again, very helpfully have the equation written out for you. So this says you're starting 40 feet down and you're coming up 5 feet per minute. So let's make a graph of that. Where do you start? Well, you start 40 feet down. So at 0, you're down 40 feet. Now, again, I have some students who do this. They went up 5. They're like, okay, I'm good. Nope. This would mean that you're infinitely deep and infinitely high all at the same time. And that's not how submarines work. They're not at an infinitely deep depth and infinitely high altitude all at the same moment. You need to put a slanted line so that it shows change over time, not everywhere at once. Because if you do this, you're kind of everywhere at the same instant. So let's go like this. So you're starting 40 feet down and you're coming up 5 feet per minute. So this means that after 8 minutes, you'd have reached the surface. Cool. Let's go on to the next one. Suppose you are at Albertsons. Now, this is not my house. It's spelled wrong. This is the store, Albertsons. And sometimes you see stores, Albertsons stores, they're grocery stores. Anyway, let's suppose you are at an Albertsons grocery store, which is 10 miles from your house. And at noon, you begin walking home at a pace of 3 miles per hour. Helpfully, we have the equation written out right here, that you're 10 miles away and you're reducing that distance from home. The distance from home is getting less by 3 miles an hour. So where should we start? We should start at 10 miles away. That's at the 0 point. Our y-intercept is at 10. And we're going to come down 3 every hour. All right, there you go. So you can see that you would get home at about 3 1/3 hours. So that would be 3 hours and 20 minutes, if that was the question. Cool. Let's continue. Superman is going to save Lois at a rate of 4 miles per second. And he starts 23 miles away and starts rocketing toward her at 4 miles a second, which is fast. Let's think about that. 4 miles a second. How many miles an hour is that? Well, that would be times 60, 4 times 60 to put that into hours. So that would be 240 miles an hour. Boy, now that I say that out loud, that actually seems kind of slow for Superman. I thought he could fly like, 1,000 miles an hour or something. But anyway, maybe Superman is not that. He knows he doesn't have to go that fast to save Lois. He's got time. Okay, he starts at 23. Now, I don't see 23 on this graph. I see 22 and 24, so I'm going to go halfway between, and that gives me 23. Then I'm going to go down 4. Now, do I go 1, 2, 3, 4? I do not. I have to count using the scale over here. I'm at 23, 22, 21, 20, 19, because 23 minus, let's get over there. There we go. So if I go down 4 from 23, it's going to be to 19, and then I got to go over 1. So make sure you're counting that one carefully. This one's going to require you to be a little more careful. When you arrive at the family reunion, Uncle Antonio has already eaten 4 mini hot dogs, and he keeps eating them at 6 hot dogs a minute. Crazy. So we have the equation right here. So what do we need to do? We need to start at 4, blink, and we're going up 6 every time. So we're going to go up 6 every time. So you don't just go up 6, you go up 6 every time. That means over 1. Up 6, over 1. Up 6, over 1. Cool. Very good. Let's go on to the next one. Prince John, this is from Robin Hood. Prince John has 20 bags of gold. While he's sleeping, Robin Hood steals 1 bag every 2 minutes, I guess because he has to climb down out of the window and back in. So we're starting with 20 bags of gold, and we're going down 1 and over 2. So we're going down 1 over 2. I got to see the scale here. Oh, there's 2. So down 1 over 2. Or you can look at the large boxes and go down 1 over 2. That works too, like these gray lines. Or you can even think of this as going down a half every time. So down a half, down a half, down a half, down a half. So you could think of it as Prince John is losing a half bag of gold every minute. Or he's losing 1 bag every 2 minutes. And that's really the same thing mathematically. It works out the same. You can, and there's a picture of Prince John sleeping while Robin Hood is stealing the bags of gold. Oh, all right, let's go down and click that submit question. There we go. And one more. So this one's the hardest one. Suppose you were given $600 from your uncle. You deposit that money in a bank and add $35 per month. Write an equation to model this situation using M for months and S for your savings. So we're not using X and Y, we're using M and S. So your savings is equal to $35 a month, except you also get the $600 from your uncle. Here's my equation. Now you can think of this as y and x. Y is equal to 35x plus 600. We're going to use the M and the S because they asked us to. So your savings is equal to $35 a month plus $600 that stays the same all the time, because that's just a $600 pile of money that your uncle gave you. Cool. So how would you figure out how many months it would take to save $10,000? First, 10,000, is that your savings or your months? Well, it's not months. Ooh, see? Oh, almost went to months. That's your savings right there. That's an S number. So let's put that in place of the S. So $10,000. To get there, the only way to do that in your life, in this story, is to do $35 a month and then add your $600. That's what you do. So I just replaced the X with the number that we hope to get. And then how long would it take to get $10,000? Well, here's what I would do. I would open up Desmos, and let's kind of shrink this down a little bit. And you could do this on your Chromebook as well. I'm going to kind of shrink this over here. I'm going to open up a new tab for Desmos, open my graphing calculator. I'm going to pull my picture over here so it's out of the way. And let's put the first one, y equals 35x plus 600. Now, you may notice, you say, Albertson, you just switched the M and the S for y and x. Yeah, I did, because computers really like x and y. And if we can get this out of the way for a minute, let's zoom out a little bit. And there we can see our red line. And it's going up. That's our savings. That's how much we're saving. And we're saving. And what we'd like to know is, when does it get to $10,000? Well, it's somewhere right in there. But let's make this easier on ourselves. What if we make a second line that says y is 10,000? That makes us a flat line at $10,000. This is just kind of a handy little trick you can do. And then you can click right where those two cross. And so now we see that when you get to $10,000, that's that right-hand number, you're at 268.571 months. Oh, what just happened? There we go. I got too many things in the way. Here we go. So you got there at 268.571 months. Now, you might say, well, is there any other way I could do this? Yeah, you could. The other way you could have done this is to subtract 600 from both sides. And that would give you 9,400. And here, I'm going to pull up a little calculator. Well, we can do it on Desmos too. So over here, you've got your 35x plus 600 equals y, right? That's what we have. If you subtract 600 from both sides, is equal to 10,000. Let's get that right. There we go. If you subtract 600 from both sides, you'd get that 35x is equal to 9,400. I just subtracted 600 from both sides. Then if I divide both sides by 35, I get my 9,400 divided by 35. I'm just using algebra here. And I get 268.571 and so on. And that's exactly what we put in our box. So you could use two-step equations algebra to solve this as well. All right, thank you so much.